So for this, what do you think the sign of delta H is? How many people think it's less than 0? People think greater than 0? How many think it's not obvious? There was no thermometer, so it's not absolutely certain that that thing was giving off heat. But if something's glowing red like that, it's almost certainly giving off heat. So delta H less than 0. How about delta S for this reaction? How many people think delta S is less than 0? How many people think it's greater than 0? A little bit of a split. So I don't think there's anything in the experiment that necessarily tells you what delta S is, just from the fact that it occurs. So it's H driven. So we found the driving force for the reaction. The only thing we can say about entropy is if it's not entropy driven, entropy is not really the determining factor. So it could be that entropy doesn't want this reaction to occur, and so enthalpy is what's winging the day. And so what we have is just chemical reasoning that if you have a solid and a gas going to form a solid, you're losing gas as the reaction occurs. So that means delta S must be less than 0. Gases have a lot of entropy compared to solids, so converting from a gas to a solid is going to lower your entropy a lot. So those were two examples that cover the range of one driving force. The first reaction was one where any endothermic reaction must be entropy driven because it's occurring and enthalpy doesn't want it to occur. And then there's many reactions where enthalpy wins and entropy would prefer it wasn't happening, but delta H dominates over T delta S.